Kia ora. My name is Jill Jolly, and I'm delivering this presentation on behalf of Dr. Nick Horsball. We both work at GNS Science Te Puao in Aotearoa, New Zealand. Over the last few weeks, Nick has been heavily involved in the response to the extreme weather events here. He has been undertaking forecasts and assessment of impacts for emergency management, and so is unfortunately not available for today's session. Nick's involvement underscores the importance of the work of Geological Survey Organizations to support responding agencies. In this talk, however, I will focus on long-term disaster risk reduction activities and illustrate our work with two case studies. GNS is a Crown Research Institute of New Zealand and was formed in 1991 through the amalgamation of several different components of the research system. Although no longer a Geological Survey Organisation in name, we undertake many of the functions of a GSO, as well as a wide range of other research. We organise our science into 4 themes, seen here, of which natural hazards and risks is our largest research area. Our other research areas are environment and climate, energy futures, and the underpinning land and marine geoscience. The importance of understanding our interaction with the Maori world is integral in all we do. By incorporating Maori knowledge, mātauranga, and understanding and engaging with Maori with respect and using Maori protocol. Ultimately, we aim to create a cleaner, safer and prosperous Aotearoa New Zealand for all New Zealanders. The Natural Hazards and Risk theme has 6 focus areas, and our work includes the National Geohazards Monitoring Programme, GeoNet, underpinning research on hazard processes, stewardship of the national hazard and risk models, and social science to build community resilience. As a Crown Research Institute, we are not wholly central government funded, although we have very strong connections into government systems and processes and legislated responsibilities under the Civil Defence and Emergency Management Act. In a geological hazards event, we provide trusted science advice to the National Emergency Management Agency and other parts of the emergency management system. For this talk, however, I will focus on the role of our science in building resilience and long-term disaster risk reduction. In GNS Science, we undertake work that covers the full science value chain for disaster risk reduction, from monitoring and data collection through underpinning science, hazard, risk, and social science and communication. For example, for seismic hazard and risk, is shown here with the range of specialist skill sets that form our capability. A similar value chain can be articulated for the other geohazards that fall within our mandate: volcanoes, landslides, tsunami, and other coastal hazards. In our work, we are guided by the National Disaster Resilience Strategy, which aims to build a resilient country across all dimensions of resilience and at all scales from individual to national. Underpinning the successful implementation of the strategy are knowledge, research, data, and assessment. In this presentation, I will show 2 examples of how our work in GNS Science specifically contributes to increasing economic resilience and resilience of the built environment. In my first case study, I'll demonstrate how our work supports economic resilience. As context, Aotearoa, New Zealand is one of the most insured countries in the world, with about 95% of our residential stock having building insurance. We also have a public insurance scheme run by Toka Tuake EQC for the residential portfolio, which covers a portion of the financial losses due to natural hazards. Quantitative risk information is critical for both market insurance premium setting and ensuring Toka Tuake EQC can purchase international reinsurance for its own portfolio cover. GNS develops risk models to inform this decision making. Our work includes developing models of the geological hazard, exposure, and vulnerability. And these models are then combined in multi-hazard risk assessment software. Different components of the risk models are used by researchers, stakeholders, and vendor risk models as inputs to financial risk modeling. Continual improvements of all these components is needed to take into account new science discoveries, changing exposure and demographics, and changes to the legislative or regulatory instruments such as building code or land use planning. Overall, improved knowledge reduces uncertainty in the risk and allows better financial planning. Two of the key components of the seismic risk value chain are the National Seismic Hazard Model led by Dr. Matt Gerstenberger and the Riskscape modeling tool led by Dr. Nick Horspool. The National Seismic Hazard Model was revised over the last 2 years and published in October last year. Riskscape has an open source platform for research and is available for wider use through a commercial license. And I'd encourage you to go to these websites for more information. A key point of both these programs is that they are highly collaborative. The National Seismic Hazard Model included contributions from multiple agencies and science organizations. Riskscape is a collaboration between GNS, our sister agency NIWA, another Crown Research Institute, and Toka Tuake EQC. Moving on to the second case study, this is focused specifically on the Wellington region. The capital city of Aotearoa is Wellington, and the region as a whole is a home to over 500,000 people. However, it is located on an active fault that runs directly through the CBD, as you can see on this diagram. The CBD is in here. There are also a large number of active faults around the region that could produce severe ground shaking, liquefaction, landslides, and tsunami. It is a steep and hilly city, and routes for roading, rail, and infrastructure are focused on 2 main corridors in and out of the city, many of which traverse the Wellington Fault, and are therefore susceptible to multiple hazards. The Wellington Lifelines Group is a group that coordinates the risk management of all utilities across the region. The Kaikoura earthquake in 2016 had significant impact on the region, even though the main surface rupture was between 50 and 200 kilometers from the city. So the Lifelines Group decided to undertake a study to identify where the most effective resilience investments in critical infrastructure should be made and over what time period. Our hazard risk and social science was used to inform this work. A design event of a magnitude 7.5 earthquake on the Wellington Fault was applied to current infrastructure, and risk modelling informed where impacts would occur and estimated potential outage times. Next, a series of workshops facilitated by social scientists worked through interdependencies between different infrastructure pressure points. For example, if the road here was damaged, how would that affect repair crews reaching major water pump stations, electricity distribution points, or cell phone towers? A series of investment options were then explored, such as building alternative roads, such as this one, or water pipelines, such as one across the harbour here. And then the impact on the restoration times was recalculated. This resulted in a prioritised investment programme that was used to approach central government for major funding. The overall impact of the investment options on business continuity and other metrics, including the costs of reduced displacement of the population, reduced direct losses, overall regional and national GDP, and improved well-being, was calculated using an economic modelling tool called MERIT. In the 2 diagrams here, you can see the overall outage time decreased significantly between the current state here and with the resilient measures applied here. For the preferred investment option, it was shown that over a 5-year post-event period, there would be a reduction in GDP loss of over $6 billion on recovery costs. This was then used to demonstrate the cost versus benefit of the investment package. As with the other programs I mentioned previously, partnerships between science organizations with different skill sets, as well as co-production with the stakeholders, was critical for the success of this work. In summary, GNS, the Geological Survey Organisation for New Zealand, has capability across the science value chain that can be utilised to enhance disaster risk reduction and resilience. Partnerships and collaborations are critical to the success of this work, so that data, tools and risk reduction advice are useful, usable and used in decision making. Ngā mihi nui. Thank you very much for listening.